So we now come to the third part of today's event, and I am very, very, very excited to introduce our next speakers. We have two speakers, and these are Andy Woods and Adam Storm from Cockroach Labs. Andy leads the SQL product area for CockroachDB, the world's most advanced distributed SQL transactional database. Andy is an author on Cockroach Labs SIGMOD paper and holds a master's in business administration from Kellogg College of Management at Northwestern University. He's also an avid basketball and soccer fan and enjoys cooking, eating out, and traveling in non-COVID times. Adam is a director of engineering at Cockroach Labs. In his more than 2 decades in the database industry, he's worked on various aspects of database technology, including self-managing databases, transaction management, accelerating analytics processing through columnar storage, and novel database architectures to separate compute and storage. He is a frequent public speaker, and he has co-authored a number of academic papers. Currently, Adam is focused on enhancing the user experience of multi-region workloads running on CockroachDB. So with that, I'd like to welcome Andy and Adam. Hello.
Hello, how's it going?
It's going very well. Let's get the name labels here. All right. So it's really nice having you join. I don't want to take up time from your presentation. Do you want to share your screen?
Yeah, absolutely. Let me go ahead and do that. All right. Let me share the screen here.
All right.
Back over. Let's see. Everyone can see. All right. Let me just make sure this all works. Oh, you see present view. All right. Hold on 1 second. Okay, great. Yeah, well, we are very excited to be here. My name is Andy. I'm a product manager here, and I'm very excited to talk to you about SQL, Cockroach, and multi-region, and why we think that that's kind of the future of applications moving forward. Adam, would you like to introduce yourself?
Sure. As was previously mentioned, I'm a director of engineering at Cockroach Labs, and I'm focused on the user experience around multi-region workloads.
Great. All righty. So we want to talk to you today about multi-region applications and why we think that they're the future, and talk a little bit about the challenges that people have had in building multi-region applications and how we get into these kinds of things. So nearly every capability that you would really want out of a multi-region application and the database that backs it up is really around providing an excellent user experience at scale. And we kind of think about 3 kind of components of the user experience here around low latency, high availability, and data domicile. So we're going to talk a little bit about each one of those here. The first is really around latency, right? And so, the idea here is that, your audience is everywhere and they expect a great experience, right? And so, when we think about this, if you have an application and a database in a single region, anybody that's not in that region is going to have a delay or going to have a latency in accessing those services, right? And so there have been some sort of well-publicized studies from some of the big, companies that operate at scale, right? In which, Amazon had this study a few years ago now that said that 100 milliseconds in additional latency lowered their sales by 1%, right? Because people just wouldn't tolerate the additional delays, right? There's nothing worse than trying to go to a website or go to a service and just waiting for something to happen and sort of not recognizing it, right? And Marissa Mayer also gives a great talk about this, where she talks about each, introduction of additional latency when people are doing Google searches actually dropped return usage by 20%, right? So the more time you had to wait for results, the more time you had to spend, in these latency delays, the worse you viewed the product and the more willing you were to try another product out instead, right? So, latency really is a big component of this. The second we talk about a lot with multi-region applications is around availability, right? And so if your application isn't up, your database isn't up, then people can't use your services. It doesn't matter how good they are, right? And so it can be really costly both from outages and from an opportunity cost perspective if if your services goes down, right? And so we actually talking to a regional commerce company that they might not have thought that they were a multi-region company, or they were operating across multiple regions, but maybe not across multiple continents, or at the scale of a Google or an Amazon, right? But they actually had a natural disaster that came through their area that almost took out both of their self-hosted data centers. Luckily, it just kind of narrowly missed the second one, right? And so having a reliance on a specific geographic location can be really impactful and really make it so that people really can't get that great user experience with your product. The last we talk about is really something that's been picking up a lot over the last few years, which is that different regions in which you operate in might have different regulatory or compliance perspectives, right? So we hear this a lot with the GDPR, although there's laws or similar laws like this, it seems cropping up almost every day, right? And so increasing number of these regulations mandate about keeping data in the same region as users, and this can really mean additional cost and operational complexity to think about how to comply with these regulations, and can put a lot of challenges on your business to do so. So if there's a lot of value in having a multi-region application and a multi-region database to support that application, you kind of might be wondering, why do so many applications remain single region? Why do they sort of language out these benefits or these opportunities? Why don't everybody get to sort of build with the same scale and opportunity that some of the larger tech companies have, right? Scale is really where a lot of the money can be at for applications, right? And so to talk about that, we're gonna go back in time a little bit and talk through a few different examples here of how sort of things have evolved in the database market in terms of multi-region, in order to sort of set the stage for where we think the future is going here. So the really most simple answer is that multi-region databases and applications have never really been easy to do at all. They've been quite challenging. Legacy databases, the Oracles, et cetera, of the world, they started as single machines. They had large, really big machines, vertical scaling. They introduced sort of this notion of active passive availability, and these worked really great until scale got to be a concern beyond what a single big machine could do, and where you wanted to have that sort of low latency experience in multiple regions, right? And so this additional scale kind of, a good example of this would be Google actually, its AdWords product was originally backed by MySQL, and MySQL was a great database that sort of let them really do all the things they wanted to do. But what happened is they started getting more and more traffic, more and more people using their product, and it couldn't keep up with the scale that was happening here, right? And so it sort of pushed the company to think about sharding, right? And so for those of you who are not super familiar with sharding, this is the idea of splitting up portions of the data onto different database servers, right? And so the idea is that you put a certain amount of data on one server, a certain amount on another server, and so then those servers can use resources independently, right? And so there won't be as much challenges of an interaction with them. But the problem with that is that as you start to increase the number of shards, there's a lot of work to be done to keep these things accurate, to keep them up to date. The application has to know about all the shards that exist and how to find the right data and write to the right places. And it can introduce a ton of operational complexity to the point where you're forming engineering teams purely to sort of true up what's happening across all the different shards in the process here. And so this asynchronous replication of kind of keeping things in the loop and keeping on top of each other really just introduced all this kind of operational complexity, right? And so you see at this point that a lot of the companies that really are pushing this scale and pushing the same experience across multiple regions really start to think about investing in their own database technologies in order to solve this, or heavily promoting new database vendors that can help here, right? And so a new wave of databases came in after this that introduced this notion of sort of active availability, so you're always available, you're always able to serve customers, and they did this through asynchronous replication and eventual consistency. And so the idea is that you have different nodes or different access in different places, and these things are kept in sync by sort of the latest writer always wins. This is an idea popularized by Cassandra, for example, and other places. And so what happens is that things are trued up eventually, right? That's what we say when we mean eventual consistency here. But that introduces a lot of problems because, what if you have a bank account, for example, and there's access from two different parties, the later one wins, right? And so there's all this work to sort of true up what's actually happening from the application and customer's perspective at the eventual consistency layer. And it introduced a number of problems kind of that that are still out there and still pervasive in a lot of the newer databases that came after the legacy databases. So when we talk about the challenges of going global, or the challenges of accessing and dealing with a lot of these challenges, you might sort of wonder a little bit in your mind, like, well, why couldn't a lot of these companies pivot to provide a great multi-region experience? And the answer is that it's really difficult to do so, right? You really kind of have to be architected from the idea of multi-region from the very beginning in order to actually provide the great experience that you would want out of a database like this, and so some of the newer databases really do start to move the needle in this direction, but they have their own set of problems that we'll talk about here. As we engage on this slide. So, as we start to talk about latency, for example, one of the realities of, a service that lets you have low latency right now is that many of these newer databases actually sacrifice consistency and the ability to leverage SQL, something that application developers really need in order to make development easy. We saw other options today, and, there are different models that are out there, but I think, giving up consistency really does introduce a lot of operational complexity. And SQL is it's an old language, but it's a battle-tested language that people understand, and provides performance at scale, and really has stood the test of time in the process here. And so this is one of the challenges with getting that low latency experience with some of the newer databases. You could think of things like Cassandra or DynamoDB or other options in this place where you're making some of these trade-offs here. The second angle is around availability, right? So many solutions trade this high availability for this eventual consistency we were talking about. And this is a challenge, right? Because on the one hand, it's great to be available and to always be able to be accessed and service information to your users. But on the other hand, like, if that information is not the right information, then it's kind of a false availability, if you will, or a challenge, at least in terms of figuring out exactly what should be accessed here, right? And then the last one that we've talked about here is around compliance, right? And, again, it's like a lot of the opportunities in order to support compliance require you to sort of have equivalent databases in each of the regions in which you want to operate in. And so this makes it complicated. You have to keep this, schemas in sync and keep everything up to date. Your application kind of has to go back to that notion of sharding to know which area or which part of the database or which database to access for different ones. And so, there's a number of challenges, right? And so the final thing I want to mention is that there are some databases that have tackled parts or some of these realities or challenges, but one of the things that has happened is that a lot of them actually suffer from cloud service provider lock-in. And so, for GCP, you could think of this as Spanner, or AWS for DynamoDB, in which, by choosing one of these options, you're actually constrained to also choose that as your hardware and networking option, right? And so that means it's not just a decision around which database is the right one, but it becomes tying you to the prices and the challenges and the whole entire stack in the process here, right? And so this is a kind of another challenge that exists with a lot of the options that are out there right now in the database market in order to support these multi-region experiences that we want to be able to provide to our customers, that really help us scale and get to the size of impact and company and expectations and profitability that we all want to be building applications towards getting to. So I think from there, I'll pass it over to my colleague, Adam, who will talk a little bit more about how Cockroach thinks about responding to these challenges and expectations from our customers.
Thanks, Andy. As Andy mentioned, there's been a revolution in database technology over the last number of years, partly as a result of the need to handle multi-region applications. We say revolution instead of evolution because if you look at the most viable multi-region technologies of today, like Cassandra and Spanner and CockroachDB as well, they're all relatively recent inventions. Why is that? And that's because it's difficult, as Andy mentioned, to evolve an existing commercial database system to handle the specific needs of multi-region workloads. It's for that reason that we at Cockroach Labs believe that a multi-region database management system should have the specific needs of multi-region baked into its core. With that in mind, let's take a step back and talk a little bit about CockroachDB's history. So CockroachDB's first architecture document was published in 2015, shortly after the company was founded. And in it, you can see an excerpt of it here, that right at the top of the document, our founders called out the need to support global workloads in a consistent fashion, no less. This bold statement in the architecture document started the journey of building a database designed at its outset for multi-region workloads. At the time, building a multi-region database was a very ambitious goal, and now 6 years later, it's no less ambitious. The architecture under the covers is designed to handle multi-region workloads in a number of ways. First of all, CockroachDB, unless you're running it in test mode on a single machine, always runs with multiple nodes and replicates data between nodes for durability and availability. If nodes fail, the other nodes in the cluster which hold replicated data will take over from where the failed node left off without a disruption to your application. Additionally, while replication of data isn't novel per se in the database space, we've spent an enormous effort ensuring that the database performs well, regardless of the location of the nodes. While there's no getting around the limits of the speed of light, we've worked hard to ensure that most multi-region transactions require only one synchronous round trip between the distant nodes. As I'm sure you can appreciate, as the nodes in the cluster get further apart, this optimization matters more and more. The end result is that CockroachDB's distributed transactions are often an order of magnitude or more faster than many distributed transaction protocols, especially as the distance between those nodes increases. In practice, CockroachDB has several customers that are running multi-region databases with nodes that are thousands of kilometers apart. Finally, we've built in mechanisms to the database to allow for data domiciling. It's possible to configure a CockroachDB database and say, keep this table in Europe and this table in the US. And the system will ensure that while data is replicated, it will never be replicated out of those confined or specified regions. This functionality can dramatically simplify the configuration of a multi-region database that has data domiciling requirements. We've also made some changes in our upcoming release of CockroachDB to provide an easy-to-use and rich multi-region experience. And now you can simply create a multi-region application on CockroachDB in 4 simple steps, which I'll outline here. In the first step, you deploy your nodes to multiple regions and specify each region name on the locality flag when starting up the CockroachDB node. Note that this step's only required for self-hosted users. If you're running on Cockroach Cloud, which is our managed service, the locality flags will be set up for you automatically. In the second step, you have to create a database which leverages the new cluster regions. And this simply requires adding the region name to the create database statement. You're also able to specify on database creation whether or not you want your database to be able to survive a full region failure. Doing so makes your database much more resilient at the cost of slightly slower writes because we need to contact neighboring regions to establish quorum in the write process. In step 3, you need to choose one of 3 table patterns to use, and each of these table patterns have their own latency characteristics. Regional tables are optimized for fast reads and writes in a single region. Regional by row tables are optimized for fast reads and writes where the fast region can be specified at the individual row level. This allows a single table to span multiple regions, but have individual rows optimized for different regions. You can imagine that such a table would be useful to store user data where your users span the globe. We've also built some intelligence into the system for regional by row tables. Since each of the rows in the table need to encode the location of that row, but we don't want to burden user applications with knowing which region to specify, the system will automatically place a row in the region in which it was inserted. This is done under the covers automatically and completely transparently to application developers. Finally, there are global tables which provide fast reads from all regions at the expense of slower writes. And this is a pattern that's useful for read-mostly data which needs to be accessed from a number of regions. It's important to note that each table is configured with a single create table statement. And under the covers, the system does all of the configuration required to ensure that the tables behave as expected. This is a huge usability improvement over systems from the past, where users had to worry and application developers had to worry about data placement, shard management, and it's all that other stuff that Andy talked about. So once you've got the database and tables all set up, it's time to start building your multi-region application. And with all the money you're going to make off your world-changing multi-region application, you might want to start shopping for that yacht you've always wanted. Since I know that the audience here cares about SQL. I thought it might be interesting for you to see what this looks like in action, along with the changes we've made in the most recent version here in bold. So here we have the SQL commands necessary to make everything we talked about in the previous 4-step slide happen. First, we start the node and we provide the region in which it resides on the locality flag. This is a flag that's specified when you're starting up the node. While I bolded the locality flag here to draw your attention to it, this is a flag that's existed for some time in CockroachDB since we've always been able to handle multi-region workloads. So in essence, nothing here has really changed. Then in the next step, we set up the database to exist in as many regions as we'd like. Here we've added the ability to specify regions on the create database statement. Of note here is that the user must specify one region to be the primary region. And this is the region that will serve writes for the database by default if you don't change any of the table locality patterns that I mentioned above. So it's important to set this to the region that the bulk of your users reside in. If that region, like if the distribution of your users changes down the road, it's possible to change the primary region easily using an alter table statement. Additionally, the users can specify the survival goal of the database here, which defaults to zone survivability. And what we mean by zone survivability is that the database can survive only one concurrent availability zone failure in the cloud service provider parlance. If users choose to upgrade to the region survivability, which means having the ability to survive an entire cloud service provider region failure, then all they need to do is add the survive region clause when they're creating their database or through alter database. And finally, you just need to create the tables using one of the previously mentioned table patterns. Here you can see that all we've done is added this locality clause to each of the create table statements to make it as easy as possible to specify them. And with that, you're done. You have your application ready for development. If you're interested in learning more about CockroachDB's multi-region capabilities, this QR code will take you to an overview of how you can set up a multi-region cluster of your own. And with that, we're done. And we're happy to take any questions you have about multi-region in general or how CockroachDB handles it.
Thank you so much for that. That was quite insightful and really exciting to sort of see your development. I have a couple of questions, but I also want to invite our viewers, if you have any questions, feel free to drop them in the chat and we'll come to them. And I guess the first question that might be interesting for a lot of the viewers is assuming that they're working with node.js or something like Golang, from what I understand, Cockroach is wire compatible with Postgres. And does that mean that most of the database access libraries, whether they're ORMs or query builders or even just raw SQL, are these all compatible with Cockroach, or how does that work? Perhaps you could elaborate on that.
Yeah, I can take that. So the answer is broadly speaking, yes. We draft a lot off of the Postgres compatibility with the wire protocol. We haven't implemented all of the features that Postgres has. Some don't make sense in a distributed database. Some we haven't gotten to yet because Postgres has a decade or two a head start on us. But yes, you can use any of the ORMs or drivers or things in that regard, broadly speaking, with Cockroach. Now, some of the stuff that we talked about today around the multi-region, these are sort of like brand new DDL statements. Those you might need to directly sort of put into your database yourself, but you don't actually need to change any of the queries that would come out, because one of the nice things about how all this works is that we don't require you to modify your queries in the process here to do these access patterns. And in fact, if you take this all the way to the end kind of view of this, you actually don't need to make very many changes at all to your application in order to have your database be a multi-region database and work in this process here. So we definitely aspire and believe that you should be able to program in the language that you want to, whether or not that's an ORM or coming into SQL directly and engaging on all these capabilities.
I see. And so Cockroach today can be used either, it's an open source product, right? It's an open source software, which means that users can either run it on Kubernetes or whatever sort of cluster scheduler they want to choose, or alternatively, you also have a hosted version of this, and that is known as Cockroach Cloud. And so what is sort of, how does one decide whether he should use Cockroach Cloud? Perhaps you could even elaborate on some of the, I don't want to get too deep into the pricing, but sort of how to think about choosing how to host CockroachDB.
Yeah, that's a great question. So the answer is that we provide maximal flexibility here. Whether you want to be, self-hosting your database and in charge of all of the details, and you've built up operational complexity. Maybe your organization has a team of SREs and DBAs and all this expertise in house, and you've invested in it, and you want to go that route. That's what some of our biggest customers do, right? And so it's absolutely possible for you to get a binary from us and use your own cloud provider, use your private cloud. Use really whatever setup that you want to use in that fashion. When we think about Cockroach Cloud, we also recognize that many organizations don't want to invest in the expertise to have their own SREs and DBAs on house, or have challenges finding those kinds of people to join. And so we also want to take a nod towards where we think the future of development is going, where we really want to make it as simple as developers get a connection string, right, and then can just start developing, right? They don't have to think about a lot of the operations and complexity and challenges around that. And so that's what Cockroach Cloud offers today. Is it really lets you tell us kind of where you want to operate in, what kind of nodes you want to have, and then you get a connection string and you just kind of go from there, right? And so then we have SREs in house who maintain and keep the database up, make sure that everything is healthy, do automated backups and things along those lines. And so really, it's a question of where you want to spend your time and expertise as an organization, where you want to evolve in this place. But you could do all the capabilities in Cockroach Cloud that you would do in self-hosted and vice versa. We just provide a little bit extra service and support in the Cockroach Cloud offering.
Got it. Thank you for the answer. And so assuming that I were starting to work on a project and I didn't sort of have a specific regional audience in mind, or perhaps I would say I would default to Europe, the region that say I'm in, and now it sort of comes the question of, okay, I need to sort of decide on the database region, right? That was the second step, I believe, in the 4 steps that you mentioned. Is it really as simple as just deciding to go for a single region initially, and then once I understand some of the traffic patterns and the usage patterns, I can just run a DDL query to alter the table and then go for a different kind of like regional setup?
Yeah, it sounds like you've got it. So we're trying to provide the maximum flexibility for our customers, especially as they're trying to build their businesses. And so if the database is created and defined with a primary region in Europe somewhere, and then you decide that your business grows into other regions due to demand, you can add those regions to the database simply through like an alter database add region command. And that will, one of the things that's really interesting about this work that we've done is that we've made the commands pretty simple, but under the covers, there's a lot of power in there. So that will take the data and redistribute it so that some of it resides in the US. The data that's important to the US resides in the US, and the data that's important to Europe resides in Europe, so that you reduce the latency to your customers as great as possible. And all of that's done with like a single DDL command.
Got it. That sounds pretty cool. Two more questions, really. The first question is, I know a lot of our users are used to working with serverless deployment platforms. It's quite a popular way now to sort of abstract away the whole infrastructural concerns of really deploying some kind of compute code. I was wondering, I know that you mentioned that you have this capability to do the regional per row. And I think you mentioned, in fact, that happens on an automatic basis based on where the queries are coming from. How would this sort of look like, especially, say, if you have your compute in one region? How does Cockroach know which region the request is coming from to know where to sort of store it in? Does that question make sense?
It does. It's a good question. So the way we determine which region to place a given row in is based on where the application connects from. So when the application connects from to a gateway node in Europe, then that row is going to reside in Europe. if an application is targeted at a server in the US and there's a gateway node defined, the connection is made from the application to a gateway node in the US, then the rows inserted will reside in the US partition of that table.
I see. So the only responsibility that developer has is to ensure that the users from a specific region are connecting, if that's a serverless function, to a serverless function deployed in that region. And then the rest is handled sort of auto-magically, as we like to say in the industry. Yeah, I mean, we have engineers like you who are doing all of the heavy lifting behind the scenes. And how does it work in terms of one of the big challenges, for a lot of serverless users is the fact that traditional relational databases are quite a connection-based relational database takes up quite a lot of time to initiate a connection. I mean, it's also, you have to allocate memory. That's at least the case with Postgres, which is a huge challenge for a lot of developers, wanting to use serverless platforms with a relational database. They have to introduce either an external connection puller and a lot of workarounds. How do you sort of think about this problem in the context of Cockroach? Are connections an expensive thing, or is this something that can really scale up if you have a spike in traffic, suddenly 1,000 new connections for 1,000 users who instantiate, say, a Lambda serverless function? How does Cockroach handle that?
Yeah, so it's true what you're saying, that establishing a connection can be an expensive part, a relatively expensive part of database processing. Cockroach does a few things to make that process easier. Like, one of the main ones is that the database is instantiated and is up the entire time. So there's no like bringing up a node and allocating all of the memory corresponding to that. That's really the main benefit that a database server provides, is that it's available at all times, really. And there will be this natural cost in negotiating the initiation of a connection. The way we see customers typically handle that is by trying to maintain these connections alive, so that they don't have to negotiate the connection privileges and all of that kind of stuff. The truth of the matter is that you can cache connections and stuff like that, but there's only so far you can drive down that initial negotiation phase of establishing a connection. So the best practices are really to try to keep those alive as long as possible. Andy, I don't know if you have anything you want to add to that.
No, I mean, I think that's well said. One thing that I did want to mention, because you mentioned serverless a lot, and we think that's the direction a lot of the industry is going, is that we actually have a serverless database product in beta right now, in which we are building in this direction. And so the idea here again would be sort of a usage-based model in which you pay for the resources that you consume here, and we're very much thinking about, what does this look like at the database designed for serverless, in addition to the serverless connections that you were talking about, or serverless, outside of the database component of that. And so we're definitely, we definitely have more work to do to provide the multi-region serverless experience. We talked a lot today about multi-region, but serverless is very much on our minds and something we're thinking a lot about. And so you can actually try out the beta today, or anybody here listening can try out that beta today. There's information on our website about that as well. And serverless is something that I think we're quite interested in and quite passionate about, and really view that as the end result future here that we're all working towards.
I see. So essentially, from what I understand, you're addressing both some of the technical challenges that naturally arise when you're using a serverless architecture, but you're also really focusing on providing something like a pricing model that fits for a hosted serverless CockroachDB that would sort of match this idea of like serverless compute, where you can, I imagine, scale it down to zero if you have zero traffic. Mm-hmm. Fascinating. Yeah. And then one final question for me, and I think we also have a question from the crowd if you have a couple more moments. When it comes to sort of query optimization, I know that using explain in Postgres is the way to sort of understand how a a query is executed, how the query plan works, and understanding where you might have some bottlenecks. Do you have similar functionality in Cockroach? And how do you generally sort of approach specific query optimization?
Yeah, that's a great question. We've actually been thinking quite a lot about this over the last few months, and so the same release that we were referencing earlier has a lot of improvements and changes there. But the thing is that we offer explain and explain analyze as well. And the thing that's a little bit different about Cockroach and Postgres is that, of course, we have multiple nodes. We have multiple opportunities to operate across these. We have distributed SQL, which means nodes can take advantage of, queries can take advantage of resources that are on different nodes, right? So you can sort of scale out and work on things in parallel and these various kinds of things. So we have all of the capabilities that you can see out of an explain or explain analyze from something like Postgres, but then we have more information because it's a different architecture in terms of thinking about these kinds of things. And so you can actually see in the upcoming release which nodes a query is being run against via explain. And we have a lot of information inside the SQL shell with a tool like that. The other thing that's really cool about Cockroach is that we come with a built-in thing called the DB console. And this is a visualizer that sort of tells you what's happening, what's going on with your cluster, and you can see what's happening here. And so, we have things like database pages where you can see all your databases. We actually have transactions and statement pages as well. And so these can tell you what transaction fingerprints, what statement fingerprints are run. You can filter and sort these transactions and statements. You could say, oh, which ones are taking a long time, or which ones are high frequency, or intersection of the two. And so, we provide a number of tools, whether or not you prefer to sort of see it visually via the DB console, or drive into the SQL shell, or even go into internal tables in order to sort of both find the various problems and then, get yourself a head up and clue on how to fix those problems in the process.
Got it.
To add to what Andy said, Andy, I think, highlighted very well that we have similar functionality around explain and explain analyze to Postgres. But one of the things that we've done differently is we've spent a considerable amount of effort building a cost-based optimizer into CockroachDB. And that cost-based optimizer allows us to provide significant performance advantages over vanilla Postgres in terms of query optimization. But it also allows us to customize the cost-based optimizer to handle things that are unique to Cockroach, like the ability to optimize around where data is placed geographically around the world. So we have built costing into our optimizer, which allows us to optimize for data placement and ensure that we're serving queries with the data that's closest to where the transaction was originally executed.
Got it. This is quite fascinating engineering happening there. We had a question from someone from the crowd who asked, how does CockroachDB help with sharded multi-tenancy? What is the recommended approach? So thank you, Logesh, for the question, and I'll open this up for you.
Yeah, I can try to handle that first, and Andy, if you want to chime in with your thoughts. So in terms of sharding the database, all databases in CockroachDB are sharded by default and partitioned, have the ability to be partitioned across multiple nodes, as Andy mentioned, for high availability. In terms of multi-tenancy, we offer multi-tenancy at a bunch of different levels. So you can have isolation of tenants at a table level. You can build that in at the schema level or also at the database level. I wouldn't say that we generally have a best practice there or a recommended approach. It really depends on what the application requires from a tenant isolation perspective. So there are a bunch of different approaches that can be taken.
Yeah, I think that's well said, Adam. I will just mention that we do have a number of customers that sort of operate a big Cockroach cluster that then they have multiple microservices that all touch that same Cockroach cluster. Each microservice gets its own database, has its own set of queries that access those databases. And that can be pretty powerful. One of the other things that's pretty cool about Cockroach is that you can actually do cross-database queries. So you can say, selecting across multiple database or multiple tenants or things along those lines in the nature. So I do think it sort of depends on your use case and how you're trying to use it. I always hate to give the dreaded "it depends" answer, but I think it is a valuable one in this place. But there are a number of customers that have configured it in a way that it really does provide meaningful scale to them across their different microservices, all within one CockroachDB cluster.
Got it. Thank you for the answer. It's quite interesting to hear that you can do multi-tenancy on those different layers. One final question. Could you share some, big users that our audience might know who are using MongoDB? Sorry, not Mongo, CockroachDB. Excuse me.
Yeah, I need to double check which ones we're allowed to say, but you can say that we recently did a webinar with DoorDash, which is a good example of a customer that is using Cockroach at scale. I think that there are a really interesting company that of course has scaled dramatically during COVID as everyone has sought out to get food delivery and not leave the safety of their house, right? And so this has been a customer that's been really interesting and really a fun one to work with because they're just hitting massive scale at this point, and seeing them transition to using Cockroach in order to handle that scale has been really quite challenging. We've got some of the top banks in the world, some of the top video streaming services. Really, I think what's one of the cool things about building an infrastructure company is that there are several different verticals of companies that we get to work with and use cases that we get to empower here. And so, I'm really quite enjoying the aspect of being this foundation for a lot of different companies that build their sort of future applications and future business upon. So there's definitely more on our website that we can point you to, and then of course if you want to reach out to me or Adam afterwards, we can point you in the right direction there about customers who are references and other things along those lines.
Great. Well, I'm sure that will invoke a lot of confidence in our audience. I've heard many great things in the last 4 years, I think, about Cockroach, and I'm really excited. Do you have anything else before we wrap up that you would like to share with our viewers? Perhaps upcoming things that you have, upcoming feature or releases? I think that might be useful.
Yeah, absolutely. So Adam referenced this. A lot of the functionality we talked about today is in our new release that's coming out here this month. So 21.1 is what we're calling it. So everybody should definitely be aware of that. The QR code in our presentation takes you to a documentation where you can kind of see what that looks like. But we're quite excited to share that with everyone. I think it's going to be really impactful. And of course, we're super thankful for you all inviting us to be here and getting a chance to share some of our thoughts, some of our ideas about the direction that things are going. And we're really quite excited. So we're really appreciative of the opportunity.
All right, Andy and Adam, thank you so much for joining us today. This has been really insightful and full of a lot of exciting aspects engineering-wise. So once again, thank you. And we hope to have you here again soon.
Thank you, Daniel.
Absolutely. Thank you.